How's it going, everyone? Welcome. And as you can see, I got a new style right now. But this video is not about me flexing my style and my new haircut. Is in fact is how, as a UI specialist, can we build is large scale applications by knowing the fundamentals. This is a course taught by Yvonne Ray, software engineer that worked as that previously worked at JetBrains over 3 years, and now he's currently at Meta. And he made this particular course from Frontend Master as a way to understand what are the challenges that UI especially are going to face, and what are the fundamentals that allow us to build is this web large scale applications. You may wonder, why do we need to look at that? Well, if you're going to dedicate at least to provide this service as a UI developer, okay, where now it eventually you will need to not only build features or bug fix, but also maintain that application. So because this course is not about maintenance, there is in fact now a particular course called Enterprise UI Development that is taught by Steve Keeney, again from Frontend Masters. But what is relevant for us is now to how to understand and verbalize all of these fundamentals as a way to create this story that it make sense for us as well as for you when it comes to build these large web applications, especially web UI large scale application. So for that, because this course is organizing, this is the structure of this course. When you have now the introduction, here we're going to talk about is the anatomy of a application, as well as the front end, the API, and the backend. Because this course is solely for UI development, we're gonna see is where are the areas that we as a UI specialist work every day, the patterns, as well as what are the areas that we need to look, as well as understand, as a way to see how now we can solve these particular problems in each one of those areas, using now this modern landscape from the platform, from the browser. And also we're gonna build our understanding as a way to build this UI, and what are the challenges that UI now are facing, especially UI development, UI specialists. Okay, so on that topic, okay, then we're going to talk about is the core fundamentals of API, and what is really relevant in today's video is to jump in directly to the web APIs as a way to understand first why we need to do this, why we need to look at this, because there are particular use case where we need to actually satisfy for the business need, and doing that is, back in the old days, something that is quite hacky to do that. And now, since we got is this new particular APIs called the Observer API that allow us to cover is specific use cases that are common on any web application. So for example, for virtualizations or for analytics, lazy loading, dynamic UI elements, or dynamic user interface, or perhaps you want is to now provide the ability to the users to draw on that, or to edit the content, or when it comes to actually show some graph, you want to actually those charts show that in a way that is usable and visible and meaningful. So charting libraries, or for resizing the application for or responsive design as well. Again, very narrow, specific use case that we can use as a way to solve these particular problems. And I think this is one of the things that is relevant, and it makes sense when it comes to understanding is the core fundamentals and the DOM API. So yeah. So first thing first is to look at, well, what is the anatomy of the applications, and that is made of the backend, the API, and the frontend. So because what is relevant for us as a UI specialist is to now look at the areas that we are responsible, that we care about. So for that, we look now at the API communication, how this application is going to communicate, what protocol is going to be used. And then once you get that data, once you talk to the API, once you fetch the data, how are you going to store and manage that data, right? So this is data management. And then how can we provide some of these particular use cases that I mentioned before by looking at these web APIs for complex UI. So this is the UI interface interactions, the user interface interactions. How can we handle that, right? And last but not least is the asset management. I think that over
Se perdió la señal del GPS.
what emphasis? Okay. Good. So most company out there actually is trying to merge that front end and back end and API into one, and I think I mean the entire industry will move towards that because it makes much more sense in terms in economic terms that the more aspect you can handle as an individual, the more you can monitor and add and the more you can monitor, add, the more you can monitor, maintain, the more you can build, monitor, and maintain, the more utility it'll be, the more usefulness it'll be. Therefore, it is something that it'll be beneficial for the industry, okay, as well as for yourself, because you are now being able to manage a lot of things than before. So a good example of that is like, especially with your responsibility, if you have kids or pets, okay, so the more you have, the more responsibility it is to handle that. So the idea here is that those responsibilities that you have now, try to do that in the most effective and efficient way possible while also enjoying that experience. In any case, because this is front end, right? And this is all of the area that we're responsible for, right? To do that, well, we need to know how can we actually build this user interface on the browsers, and before that, how the browser actually treat the HTML. I'm not going to get into the weeds. In fact, I'm going to mention is now how can I just to quickly, briefly describe how all of these things are connected, okay? Until we reach to the Web Complex API, and that is, well, first, we need to know is about the box model, because this is how now the browser treat the HTML when it comes to provide some style. So CSS actually is, so in CSS everything has a box around it. So once you understand how this box behave and how they interact, a lot of the time that allow you, well, or that will actually give you is that will provide you the tool set or the fundamentals needed to build this more complex UI. Okay, that's when we look at the box anatomy, and then what are the box properties? The size, which is inherited or restricted, and the types, which is block and inline and anonymous, and how not the block and the inline, each one of them has its own set of rules that these elements, that they indicate how these elements behave, and this set of rules participate in something called the formatting context, block and inline. So this formatting context, the key feature of this is saying, okay, so now that we have this way of defining layouts, okay, which one of the benefits is that we can isolate them, so elements outside of that formatting context don't affect these elements inside of that, and also is scalable because you can now is not only have one particular formatting context, block, inline, grid, or flex, or any other that spec developers find useful over the long run. So with this scalability property, right, that with each one of those contexts, things are now predictable because it has all of these set of rules. When it comes to now the browser position all of these elements, use something known as the normal flow that actually is changing. So that actually is how the browser is putting all of these elements on the screen. Okay, so you have the normal flow that is started from right to left and then the top to bottom, and then now now how you can actually is create several layers or stacking contexts that are now outside of the normal flow by using the position relative and absolute, as well as CSS class transformations. It tells the browser to create now a stacking context. Why this is helpful? First, because elements in the stacking context follow a particular properties, or these layers behave in a particular way, okay, as a way to work with other elements, so they don't move other elements, they just overlapping each one of them. And it is useful because not only provide isolation from the formatting context, elements that we can lay out here, but also is useful in terms of performance, because when you use now is a CSS transformation like transform, okay, what happened is you can now tell to the browser, hey, I want to optimize this stacking context. Why do you want to do that? Because the more element you have in a particular formatting context or a stacking context, and the more you modify it is position or width, it is position or it is geometry, the more you're triggering is CPU. There's nothing wrong with that. But there are alternative way, or there are a way of how you can, instead of actually trigger that, you now call is the GPU instead. So triggering that, those change in those elements is causing to call the reflow phase every time you modify those properties, the geometry or the position of the elements. So what is reflow? This is one of the stage of the entire assembly line, okay, of how the HTML, CSS, and JavaScript elements are, or how the browser treat all of these HTML, CSS, and JavaScript files into pixel on the screen. So you have now the DOM, the CSS object model, which is something that it transformed and then it merged to a 3 data structure. I'm not gonna talk about the data structure here, but because this audience is something familiar with that structure, and if you're not, well, data structure is a way of how can we organize data as a way to tell the computer, hey, this is how I want you to organize this data when it comes to solve particular problems, okay? Real life problems. So for example, here is that how can we now represent is a document with all of these components, okay? And when we need to actually is change the content of the HTML node or all of these elements, all of this node, how can we now is, for example, do that in the fast way possible. So this data structure is something that allows you to, as I mentioned before, organize your data for the computer. So now when you talk in those terms, and you try to solve a particular problem with those data structure, they are very good at doing specific things. So for example, linked list as a way to now provide the history, okay? As a way to now actually keep track is the anything that is sequential, by the way. So for example, the browser history. Hey, I go back and go, oh, move on, that kind of thing. All right, but in any case, so this is representing a tree data in a tree-like structure. That's right. And because now it merged to something called the render tree, where now the render tree is this representation for the computer that that say, hey, I know all the relevant data, all the information relevant as a way to now move on to the next stage, which is how I'm going to put these elements on the screen and going to calculate its geometry, its dimension, right? This is the reflow phase. This phase is triggered by JavaScript usually. So the idea here is that when you are modifying the geometry or the position of the elements, it's like, hey, you know what? This actually passed through this particular pipeline, which modify, of course, the layout, and now the browser needs to calculate that and paint that. This is something that you can prevent, and you may wonder, why do I need to prevent this to happen? Especially if you have now multiple things going on over and over and over, multiple HTML elements that you are modifying, manipulating in its position and geometry over and over and over and over. For example, every time the mouse is moved, right? Anytime you move the mouse, of course, that is quite expensive. So the idea here is to reduce that, right? So how can we do that? In CSS, there are some couple property, for example, like transform, that offer that. So instead of actually triggering is the layout phase, is actually going to talk directly with the GPU. How does it work? Is on the composite phase, where this composite phase is, I just want to actually, the composite phase on the browser, right? Popular in the page, how the browser works, performance. Oh, this is a way to, okay, oh my god. Exactly. What is this? Popular in the page, how browser works. Exactly. So now it's explaining is this, building the CSS object model, other process, JavaScript compilation, the render here, the style, the layout, right? The fourth step is the critical rendering path. It's running the layer on the render tree to compute the geometry of each node. They know that as the reflow, for example, Google called that, but it's actually the layout phase. Subsequent recalculations are called reflows. Interesting. You might wonder why they call this reflow, because subsequent recalculations or its position or geometry are calculating the reflow, the normal flow of how this element is going to lay down. Okay. And then you have now the paint and the composite, right? So on the composite, when sections of the documents are drawn in different layers, right, overlapping each other's composite, is necessary to ensure that they are drawn to the screen in the right order. So this composite layer, what it does is to actually is render those elements in the proper order, right? So these composite layers, previously we have older browsers that actually use CPU, and now we got newer browsers that use GPU, okay? So we got now these composite layers that is now the way of how the browser is going to create each one of those layers that actually are a representation of how your page is going to look like. So first is the render API tree, that's right. So it matches each one of those elements for the DOM. Anytime you create now is, or you alter the position of the elements from the normal flow, or you create a stacking context, you're creating is a render layer as well. And they're triggered by the position or the transform. And then, because this render layer is triggered based on that, the graphic layer is only triggering when you actually use is now the video or canvas or 3D or perspective transform. And this particular layer is actually how now the browser talk directly to the CPU. So all of this was interesting as a way to make sense of how can we now know the fundamental of building these UI elements, and as a way to now do something with that, to interact with those elements, we look at the DOM API. The DOM API is just a set of methods that allow us to interact and manipulate the DOM. Frameworks like React, Angular, and Vue actually provide you a layer of abstraction, so you don't have to do that manually, okay? But perhaps there's some times that you need to actually manage, or that you need to is building a low-level library, okay? These low-level libraries, okay, whether it's virtualizations, DOM management, for example, something that React actually, Angular and Vue actually doing is like, hey, DOM management or virtualization. These low-level libraries are perhaps a component for the chart engine or the video element. So you want to build a portfolio that is have a minimal blueprint on that. The idea of understanding now how this DOM API works is to see what it's doing now. For example, frameworks like that, React, Angular, Vue, and also that you can build your own thing by your own. So the DOM API exposes some global objects to JavaScript. This is not exclusive to JavaScript. You can also use the DOM in other language, okay? For example, Python. That's interesting. But because JavaScript was built for the web, that's why we can have access to these global objects. The window, the document, the head, and the body. And as a way to understand how this structure works of the DOM, we need to look at that. So it all starts with the node, that is the tree-like structure, okay, as you can see here. So property tree-like all right, the node, and then some other classes that extend from that. Node is the base abstract class that is used as a blueprint from other classes. So for example, like text node as a way to use that for adding content, or element that it now allows you to represent other specific types of elements. So for example, HTML, SVG, or any other XML element. And then we also have is the HTML document, which is something that is legacy. We inherit that. And this HTML document actually has a window object attached to that. So this is something important, because when you're going to look at the operations that we can do on the DOM, we got is we can query, add, and remove elements. So query, we got at least 4 main ways to query elements. So you got now the document element by ID, which is read cost and time complexity and memory complexity is 01, linear. You got it. It's like accessing an element on a hash map. The other is, well, get element by class name or class or tag name. This particularly are quite interesting because it uses a CSS selector, the same for the get element by ID. Okay. But this class selector is, or this class name actually is now return you as a live collection, which is a collection, is a type of collections that is live, meaning that anytime you want to access to this, the time complexity of this is linear. The same for the read cost is linear, okay, and the memory overheat is low. So because the way how now it recognizes that, it traverses using the depth breadth search, okay, the deep what in the F deep first search, right? Pre-order, so it's going to traverse all of these elements in that particular order and fashion until we find that, okay, and it returns this live collection. So when you modify that collection or that element, unfortunately you are triggering is now the reflow phase, because those elements live on the DOM and you are manipulating, interacting with them, and if you alter the geometry or the position, of course, well, you're going to be in serious, you are going to trigger the reflow. So for that, we got an alternative that is called query selector, and query selector O. So query selector is, even though it's a little bit less performant than get element by ID, but the time, so the time complexity of this depends on the selector. It can be constant or O1, right? Because the browser actually do some optimizations behind the scenes for that. So query selector return is an element, important here, and query selector or return is a node list, right? So this is important to understand what this method return as a way to make sense of how then you can work with that. Useful, especially when you need to do some third-party integrations, okay, which is something that you're gonna do. There, exactly. Completely, man. That's something that you are going to do. Yeah, it is, man. So, so for performance overview, as I mentioned before, get element by ID is, even though that is the best performance, there's some recommendations or best practice when it comes to run or for performance. And one of them is that, well, use small selectors for your elements. That's one. The other is use ID for use ID of core containers. Okay, so that you can now have access to those sub-tree in the most blazing fast way possible, and use them as a starting point to do that, right? Pick the right point, pick the right start point, and choose. So all of this is more about like use few selectors, short selectors, be precise, be consist in your selectors. Use ID for core containers, and then you need to select what is the starting point that select wisely the starting point that you want to actually interact with that element. So because in the case of query selector all and query selector, both of them, they don't return is live collections, and in fact query selector return is a copy of those elements. The memory heat is over a, so when you're doing this query selector or you can have some spike in memory here, but which can lead to degrade your performance, but what you can do is now receive is a copy of all of those elements, not a live collection, which is something useful, especially when you want to actually is now adding or removing elements. So the methods for adding or removing elements, you have all of them are horrible, but there is, but there are less horrible than others. So you got now is the insert HTML, which is one of them. You got is the inner HTML and the insert adjacent HTML. This is the worst because it needs to parse that. So this particular way of actually adding this element actually parse that content and then add to the DOM. Whereas the, for example, append child or insert adjacent element actually is performed less horrible, but still not very good. And the way to eliminate elements is, well, you can remove them for that, right? As long as they provide you an element, you can remove that, either is inner HTML or remove. So the whole point of this is to look at how can we now is by using document fragment, which is just a small piece of the document interface, that you can create on the fly, perhaps on the server, okay, and then populate that and serve that, perhaps serve that particular code, and then let the browser now, once it runs the code, it put that element there, okay. For example, in here we actually appending the elements here. The only way that we're triggering is the only way when we are triggering is a reflow is when we append the components, is when we append the child here. But when we are actually creating the user interface, in a particular case, a car, for example, we do that on the fly, and then we send that JavaScript code to the browser to actually modify that. Which is very, again, this is now pushing the limits of what now we can do. And I think, for example, frameworks like React 18 and the new versions of that, actually they are now pushing the boundaries for that, which is great. And then now actually makes sense of, it also open up to things, okay. It also open up you to things, to things like it open up you to things like why they have now available this React server components, okay, things like that. It's like, hey, just only send a small chunk of JavaScript necessary to hydrate, to provide interactivity to that. That's quite interesting, by the way, to provide that interactivity. That's why it's called hydration. It's a process of connecting the HTML and the event handler. So finally we are here, right? Web API for complex UI patterns. Now this is when the things actually make sense. It's like, because after all, everything that we have looked is to satisfy some business needs, and there is a reason why also I taking all of this particular course, because I just want to know what is the reality behind it, what is the things, how do we get here. That's one of it, because no one's owned you, because because no one owns you an explanation, and it is your job and your job alone to hone into that specific niche to get it right. So here we are. Okay, this is the use case, right? What? Okay. Because when we need the specific things, like if it's for analytics, okay, so for analytics it's like how many elements we are actually, so what are the most frequent portion of the application that our users are actually looking, or for rendering elements. Here is like, how can we now actually dynamically render elements in our application, in our e-commerce or any other applications, as well as how can we now defer or lazy loading components on demand. So when the user now actually show an intent of that, for example, like DNS prefetch, the user actually is hovering on that particular link, which is most likely to actually get that for that. And the other is for analytics, right? So how can we now solve this particular problem? What are the things that we need to actually do? And because doing these kind of things, or giving the user the ability to edit a text or draw into something, perhaps you want us to now render charts that are responsive, okay? Or you want to provide now adaptive design, okay, when it comes to draw things or render charts, okay? All of these particular use cases are very hacky. And we have to end up doing things like we tend up to utilize the we tend to utilize is we tend to utilize is, for example, the callback queue to do these kind of things. So we are now exclusively using the callback for each one of those, leaving the applications more likely to freeze, to crash or jank, because we are actually using that resource. So because of that, because that's the problem that it solves, right? The Observer API solves this particularly specific problems, okay? And I think that's quite interesting as a way to explain is that. It's like, oh my god, that makes a lot of sense. In similar, let me see, it's actually exactly analytic with intersection API. Okay, so I need to is explain more about is like in this video. Yep. Yep. I might do that. Yep, I might do that. Okay, cool. So there we go, right? The Observer API. So the Observer API now has these three classes that is behave quite different as the event-based traditional patterns or APIs, because now this provide each one of them to cover a specific use case. So for example, intersection, right? So intersection now, before that we have is to actually calculate is the position of these elements, and then if they're overlapping, using a set timeout, we're gonna trigger now is the callback for that, right? And so we to detect, only to detect that. Jesus. So anytime those particular elements are overlapping, okay, we will now back in the old days is to actually is all right, let me now wrap this in a timer, and every small amount of time, 15 seconds, I'm going to run this code, this callback, as a way to see if when the user is now navigating to that, those elements, when that time pass, actually is intersected. Again, very hacky. There was any native solution to that. There is nothing wrong with that. But as I mentioned before, it actually consumed is that particular stream, as you mentioned, right? So the interceptor observer say, well, now I'm going to observe any element that you pass me here, okay? And when they intersect, I'm going to provide you now a particularly, and when they intersect, exactly, when these elements intersect, now I want to trigger is this callback, this asynchronous callback that I'm going to trigger that. So that's great, because how we can not only is use that to actually match is the two elements, we can also use that to match is if they're overlapping with the viewport, which is another element, right? If this overlapping to the viewport, and well, you provide now the root, so the window that check the intersection against, okay, the thresholder, which is what is the minimal intersection ratio to actually trigger the callback, and the callback. So the window that we check the intersection against, okay, and here, well, this is the way how now we create our intersection observer. We say, hey, this is we first create is the intersection observer, but first you have to pass is the callback. So this is another element that we need to pass here. So this callback actually receive is the entries, which to me is quite interesting. You receive now a list of action that can happen when those elements or when that is triggering, okay. Okay, and Okay, the intersection observer entry. That's right. So it receives now an array of intersection observer entry, which is an array of entry that were triggered. Entry may intercept or may stop intercepting with object. So it is important to check is intersecting property in this particular case. But again, because this now is now a record, a list of those observer interaction, okay, you want to know when that actually happened. So this is now the entries, and the observer is the instance of the observer, which is what you're gonna do after that. You say, hey, now let me actually is observe this, or the intersection observer is that once you create now the intersection observer, and then you pass the callback as a way to what you're gonna do once these elements intersect. Okay, usually is with the viewport. All right. Then you need to indicate what are the elements that you want to observe through the observer, which is here. So things started to make a lot of sense, and yesterday we actually do that particular thing. The problem is that, Copen, that actually work is on Copen, not on our local machine. So we weren't able to run that locally because especially because the way how we are using is ES6 or ES model, and when you want to import some JavaScript files inside of JavaScript, the browser say, hey, no, I'm scary. I'm not gonna let you do that. So it's quite annoying. It's quite boring. So I get it. I totally get it. Yeah. The browsers are scary of user. The TLDR is that browsers are scary of their users. Mm-hmm. Okay. 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 So. All right. So yeah. Actually, that was quite interesting. But I won't repeat that mistake. So what I'm gonna do is to actually is now take a look at the next exercise, which is the mutation observer. Remember that at the end of the day, what is the problem that what is the problem that Observer API solve? Is that, and I prefer to talk about the intersection Observer API. So what is the problem intersection Observer solve? Okay, is that for those common use cases that I mentioned before, the analytics. So I want to look at when is the section that the user actually navigate the most, or for analytics, for dynamic UI elements. Okay, you want perhaps loading some dynamic elements once the user scrolling to that, or for providing virtualizations, lazy loading. All right. That's why this intersection observer was created. If you're gonna go outside of that, you are free to go and you are free to live your own adventure. But this is the use case that for what it was designed. Thanks, Ifni Ray, sir. Okay. So because of that, then in today's video we're gonna look now at the Mutation Observer. Okay, so Mutation Observer, right? Mutation Observer. What is that? Really? What? Do you think this is all one word? No, that's only one word. Okay. So. Mutation Observer. And let's go to create now a code pane for that. Oh, code sandbox. Yeah, code sandbox. I think that I actually have an account here. Not sure if I have an account here. Cloud sandbox, meet a CDN that makes an impact. Oh, it takes time. Perhaps the using is not the intersection observer, you know? They're perhaps using the intersection observer. I don't think they're using React, or perhaps they do, exactly React in Next. Yeah. Radix UI, Marco, Infrastructure as a Service, Google Cloud. Okay. Interesting. Very, very interesting. So, is this one. So once I pass a certain threshold, what? Well, again, the threshold ratio is that when it's triggered. This is a very good example of how you can do this, you know. The similar for this, you know, and then you got it. Okay, yeah, good, awesome. Even though this, I think that, right? Even though the instant cloud, because we load the element here, exactly. So now it's loading here, and when we pass certain threshold, oh, it had seen that the element load that. Okay. So, please, let's get into this. Now, this doesn't work. Please don't work. No. Interesting. Really? Why not? Exactly. Log in. Alright. Thank you. So yeah, let's go to create now a new one here. Yeah, there I got a lot of tests here, bounding box, that kind of thing. That's actually pretty interesting, pretty cool. Yep. Yep, it is. Reasons. No, what if I want to create a new one? Create a new one. Welcome to your new free workspace. Your free player has been updated to use base system. You can now use private sandbox. Collaborate up to 5 members. Go index box using 400 free credits. Yeah, but what if I create? There you go. A simple vanilla JavaScript. So this will be called now the Mutation Observer. Yes, it's Mutation Observer. Oh my god, I really love this. Everything is so freaking fast. Everything is so freaking fast, bro. Yeah, everything is so freaking fast.
To the Mutation Observer now.
Mm-hmm.
So the Mutation Observer is different because it allows us to track the changes within the DOM subtree. So it's very useful for rich text editors. For instance, you're trying to select some data and apply the bold text. So the Mutation Observer will allow us to detect that. The huge benefit of the Mutation Observer, it's implemented on a native level. So previously in vanilla, how this Mutation Observer would be polyfilled is you're basically creating a proxy object that would track every mutations of any possible subtree. And this is implemented on a JavaScript level, so you would need to create, like, if you have a large subtree, that would result to some memory issues. And since on a native level, it's very fast. And the creation of the Mutation Observer is pretty simple. We just need to provide single callback. There's no options to the constructor, and the callback accepts the mutation. And the observe function accepts two parameters. One is the target node that we're trying to observe. Here, in this example, it's div, and the observer options. And the observer options is a bit more complicated because we can track many things. So we can configure the observer to track only the child list. So this means that if we provide the child list true, then we're going to track the section in H1 because they are direct child of div element. If we provide the attributes to true, this means that the intersection observer the mutation observer will track any changes in the attributes. And if we provide the character data, then if we have any text content and we enter this content using the keyboard, then the mutation observer can detect these changes, like on change on the inputs, and provide us with the mutation observer entry. And there is also one cool thing, is the subtree. So we can basically say that we want to track all the elements in the whole subtree, and we just need to provide the true flag here. We can also filter the attributes that we're currently looking for, and this will reduce the number of times the callback is called. So the best practice is to make sure that you configure the observer in the right way, so you don't try not to overuse the properties. Don't set them to true, because this will involve invoking the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants, and the subtree would be any.
Yeah, invoking the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants, and the subtree would be any.
Yeah.
Thing. Okay.
And there is a conflict. If you apply child list true and the subtree true, then the subtree will not work because this child list has the preference higher priority. Okay, so the TLDR, make sure that you configure these options right to reduce possible invocation of the observer callback. And the mutation record that the mutation observer provides us is basically has a few properties. So the type tells us which type of mutation happened. It can be the attribute changed, or some data was entered or removed, or there might be that we added a new DOM element in the direct child list. So it also has the information about the target node, which was triggered the mutation observer, and we also have the added nodes array that will give us any newly added nodes that were when we inserted some data in the DOM tree, or removed nodes. And we can also access the old character data value to see what was the value before the mutation happened. And again, the callback is pretty simple. We just need to look for the mutation, filter it by our type, and write our logic. So I'm going to open this example in a full screen just to give you the idea what we're trying to build. So imagine like the markdown editor where you can replace the content with some elements. So for instance, I want to replace this element with a heading. So the idea is to build such very simple example of the markdown editor to support H1 and H2 text. So if it's H1, because I have a normalizer, it will have the same styles. But if we check the example, we'll see that there is a H1 and H3. And as you can see, we can edit the direct content of the HTML element. So this is done through the content editable true attribute. So a few good examples of such capabilities in Notion app, they heavily rely on such type of editing. So let's get back to the exercise. So first, let me move out from the full screen and go back. So we are going to utilize the same example that we used before, but we will add the content editable attribute to a section where we place the body text. And we're going to create a mutation observer and track all the subtree changes and the character data, so we can verify that we actually used H3 or H2 or H1 tag. Then we implement the callback for mutation observer, and when we type, we need to validate that the text that we typed matches the tag to replace the content, and then we will need to replace that. Make sure you're using the single observer for all rendered cards. Yeah, and let's jump to exercise. Here's the branch name to start your work. Let's get back to the code. We have the same file in the index.html file, so that our template is here.
First of all, I just want to look at, because what we want to do is to see how we can now add to that. First of all, I just want us to do something quickly here.
Let's go to the mutation observer now.
Exactly. I just want to do some quickly stuff here, man, because... Okay.
So the mutation observer is different because it allows us to track the changes within the DOM subtree. So,
okay. It allows you to keep track of the changes of the DOM subtree. So DOM subtree, right? With the mutation observer, it allows you to do that, right? Okay. Mutation observer. Good. Web API mutation observer. So if we take a look at the web API, right? Web APIs, right? You got a lot of APIs. You have Canvas. We're quite familiar with Canvas. We also have now is the HTML DOM, the HTML drag and drop, history API, and Houdini. Houdini, what the F is Houdini? The HTML drag and drop is another pain in the ass. The Interception Observer API, the Network Information API, the Payment Request API. Not sure how often do we use this and what are the wrappers around this, right? The API is available inside of cross-origin iframe elements only if they have the allow payment request attribute set on them. Yeah, that's something. This feature is available only in secure context. Yeah, that's something quite interesting. Because I'm not sure if they are actually using that. For example, Stripe. Oh, create a payment request object. Interesting. In Safari, Stripe.payment request use Apple Pay, and in other browsers it use the payment request API standard. This is something interesting because it's rarely that we use this. Oh my god, the payment request API. And this is a draft from 9 September 2024. Okay. That's quite interesting. Very, very, very interesting. Merchant validation event. Oh, and they provide some interface. Instance methods. Deprecate is no longer recommended. Okay, payment address. Deprecated. Okay. Payment method change event. Payment requests. Available only in those. Payment methods change event. That's quite interesting. Payment response. Oh, there you got. Oh, okay. This is the interface. The interface that they won't change that. Payment request. Okay. Payment method change. Payment request. Payment request update event. Payment request. Payment response. Payment response. Okay. Okay, interesting. Very, very interesting. And payment response. Complete retry into JSON. Event payer detail change. Pay your name, pay your email, pay your phone. Okay, again, this go beyond a little bit of the okay. Okay, all right. Okay, Mutation Observer. Right now, there you go. So the Mutation Observer interface provides the ability to watch for change being made to the DOM. Okay, to watch for change up to keep track. So because I really love that people actually love to change terminology and words to make the reality more soft and easy to deal with. But it doesn't matter because after all, you are being tracked. What's wrong with that? Watch. So interface provide the ability to watch for changes being made to the DOM tree. So it allows you to keep track is the change that you do to the DOM tree. It is designed as a replacement from the older mutation event feature, which was part of the DOM 3 event specification. Their design is flawed. Oh my god. Adding DOM mutation listener to a document profoundly degrades the performance of further DOM modifications to the document, making them 1.5 or 7 times slower. Moreover, removing the listener does not reverse the damage. They have poor cross-browser compatibility. Safari doesn't support DOM attribute modify. Firefox doesn't support mutation events. They have been deprecated in favor of Mutation Observer. Consider use this instead. UI event. Okay, I think we can start by looking at this. Wheel event, UI event, text event, mutation events, mouse scroll event, mouse event, keyword, input, focus, and composition event. What in the F is this, bro? Represents events that occur due to user indirectly entering text. Indirectly. How do you indirect anyway? No, not gonna. No. What? Focus on what is relevant. Mutation event. The mutation event is not part of this. That's interesting. Focus, of course, exists. Input, of course, exists. Keyword, of course. Mouse event, of course. Mouse scroll event. Okay. Mutation does not. Text event is being deprecated. Text event has been superseded by events such as input, before input, key press, and key down. UI event okay, and wheel event. Okay, but again, not everybody has wheel. Exactly the difference, the delta X, the delta G, and delta C, and delta mode. And events, out clicks, before input, blur, click, composition start, composition update, context menu, DB click, focus, focus in, focus out, input, key down, key press, key up, mouse down, mouse enter, mouse leave, and there you go. Okay, however, mutation observer. So this mutation observer allows to keep track is change in the DOM. Change made to the DOM tree. Instant disconnect, observe, and take records. Oh, so you have a particular queue here, bro. So anytime you wanna keep track things in order, you use this queue. Or a stack as well. Mutation and observer, customize resize event listener demo. Okay. Alright, okay. So, please.
So it's very useful for rich text editors. For instance, you're trying to select some. Let's go to the mutation observer now. So the mutation observer is different because it allows us to track the changes within the DOM subtree. So it's very useful for rich text editors. For instance, you're trying to select some to track. Let's go to the mutation observer now. So the mutation observer is different because it allows us to track the changes within the DOM subtree. So it's very useful for rich text editors. For instance, you're trying to select some data and apply the bold text. So the mutation observer will allow us to detect that. For instance, you're trying to select some allows us to track the changes within the DOM subtree. So it's very useful.
It allows to track DOM elements within a subtree. It's very useful for rich text editor. It's very useful for rich text editors.
Useful for rich text editors. For instance, you're trying to select some data and apply the bold text. So the
for example, select some data and apply some bold text. Okay, you select the data and you want to now apply this bold text. Okay, so you are mutating is the observer API. Oh, you are mutating is the elements inside of it.
The mutation observer allows us to
God.
detect that. The huge benefit of the mutation observer, it's implemented on a native level. So
Exactly. The advantage. Okay, the advantages is that is implemented on a native layer.
previously in vanilla, how this mutation observer will be polyfilled is you're basically creating a proxy objects that would track every mutations of any possible subtree. And this is implemented on a JavaScript level, so you would need to create, like, if you have a large subtree, that would result to some memory issues. And since on a native level, it's level, so you would need to create, like, if you have a large subtree, that would result to some memory issues. And since on a native level, it's very fast. And the creation of the mutation observer is pretty simple. We just need to provide single callback. There's no options to the constructor, and the callback accepts the mutation. And the observe function accepts two parameters. One is the target node that we're trying to observe. Here, in this example, it's div, and the observer options. And the observer options is a bit more complicated because we can track many things. So we can configure the observer to track only the child list. So this means that we go if we provide the child list true, then we're going to track the section in H1 because they are direct child of div element. If we provide the attributes to true, this means that the intersection observer will, or the mutation observer will track any changes in the attributes. And if you provide the character data, then if we have any text content and we enter this content using the keyboard, then the mutation observer can detect these changes, like on change on the inputs, and provide us with the mutation observer entry. And there is also one cool thing, is the subtree. So we can basically say that we want to track all the elements in the whole subtree, and we just need to provide the true flag here. We can also filter the attributes that we're currently looking for, and this will reduce the number of times the callback is called. So the best practice is to make sure that you configure the observer in the right way, so you don't try not to overuse the properties. Don't set them to true, because this will involve invoking the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants, and the subtree would be any.
Yeah.
Okay.
And there is a conflict. If you apply child list true and the subtree true, then the subtree will not work because this child list has the preference higher priority. Okay, so the TLDR, make sure that you configure these options right to reduce possible invocation of the observer callback. And the mutation record that the mutation observer provides us is basically has a few properties. So the type tells us which type of mutation happened. It can be the attribute changed, or some data was entered or removed, or there might be that we added a new DOM element in the direct child list. So it also has the information about the target node, which was triggered the mutation observer, and we also have the added nodes array that will give us any newly added nodes that were when we inserted some data in the DOM tree, or removed nodes. And we can also access the old character data value, the information about the target node, which was triggered the mutation observer, and we also have the added nodes array that will give us any newly added nodes that were when we inserted some data in the DOM tree, or removed nodes. And we can also access the old character data value to see what was the value before the mutation happened. And again, the callback is pretty simple. We just need to loop for the mutation, filter it by our type, and write our logic.
Okay. pretty simple. It's pretty simple. Mm-hmm. Mm-hmm. It's pretty simple. It's pretty simple. No. Well, what in the F is this?
All the elements in the whole subtree, and we just need to provide the true flag here. We can also filter the attributes that we're currently looking for, and this will reduce the number of times the callback is called. So the best practice is to make sure that you configure the observer in the right way, so you don't try not to overuse the properties. Don't set them to true, because this will involve invoking the callback too many times. So just make sure.
So just to clarify, the child list would just
The specification provides us is basically has a few properties. So the type tells us which type of mutation happened. It can be the attribute changed, or some data was entered or removed, or there might be that we added a new DOM element in the direct child list. So it also has the information about the target node, which was triggered the mutation observer, and we also have the added nodes array that will give us any newly added nodes that were when we inserted some data in the DOM tree, or removed nodes. And we can also access the old chart data value to see what was the value before the mutation. And again, the callback is pretty simple. We just need to look for the mutation, filter it by our type, and write our logic.
Okay, this observer is now tracking is this element whenever it changed. Whenever any of its elements change, or the
So
other
I'm
one.
going to open this example in a full screen just to.
Okay. So that'll be all for this video. Take care. Bye bye.